So you might ask, residuals, where do these actually come from? Where do you think residuals come from? There's a very logical, real-world explanation for this.
Either from errors in the calculation, or maybe there were more independent variables that you didn't account in your model.
There are probably more independent variables that we didn't account for in our model. Probably some more things, many more things, that determine how many drinks a person orders. Yes, there must be simply other factors at work as well. And that is a very common phenomenon. You could even say, well, anytime we don't have a perfect correlation, that must be because there are other factors at work. Other factors than the one independent variable that we have measured at this point in time. The residual is always caused by those individual characteristics of the person. As I said, this individual was a greedy student. Maybe they just didn't want to order more drinks, even though their throat was parched as a result of those 6 appetizers. Who knows? That could be one individual characteristic that causes them to behave a bit differently than the general trend in our sample. What else did I want to say to this? Yeah, so basically it's like individual differences and measurement errors, random measurement errors, if we want to be extremely precise about this. Although you could argue a measurement error is also just something else in the process, another factor that also influences the drinks. Well, so what you could say is that the line has been drawn in such a way that the points follow that line as well as possible. This is what we said earlier, right? This is an attempt to make that more formal. What you could say is the line we have drawn was chosen this way, such that the residuals are all as small as possible. Specifically, the mathematical criterion is that if you square these residuals and you add them all together, and the sum of those squared residuals should be minimal. That sounds very technical at this stage, most likely. Perhaps in a later part of this series, the least squares criterion will become a bit clearer, but let's just say for now that there are, you need some kind of rule, right, to decide what is the optimal line through your scatter plot. We have decided on drawing the line in a particular way, and the formulas for A and B were actually based on this criterion. So when mathematicians were inventing regression, they decided, at least that is what the kind of regression we talk about, they decided we want to make a regression line that causes the residuals to be minimal. And this is then a way to formalize that. And the formulas for A and B were chosen such that they satisfy this criterion. That's how you could see it. There are many other ways to draw a regression line which are based on a slightly different mathematical criterion. But who knows, maybe this will become a bit more tangible up ahead. If not, I don't think it is super important, honestly, at this point in time. But maybe it gives you just a bit of footing if you have heard of this criterion elsewhere.